is how to do multiple path payments. So there's a question even like, why do we even need multiple path payments? So if you have a channel, we don't have them now, so are we really hurting for them? So I kind of like describe different situations where you would need it. So in the first quadrant, you can see like I have two channels. One of my channel has 3 coins on my side. I want to buy something that costs 2 coins. So that's actually a situation where we're fine today. That's normally what's happening is that we want people to make channels that are big, that are going to be able to accommodate multiple repeated purchases. That's kind of like the whole idea of channels. So that's why, like at the moment, we actually don't have a huge problem as far as needing multiplexing different channels together. And in the second quadrant, you can actually see that if you have 2 channels where you don't have insufficient balance, but you actually have inbound capacity on one of the channels, it's actually still possible even without multiplexing payments to pay for that 3 coin item. And the way that would work is you can actually move funds from channel A to channel B. And then, so you can see that like in the second quadrant, you can see like there's, I have 4 coins total, but they're split up incorrectly. So I won't be able to, just naively, I won't be able to buy this 3 coin item. But in my second channel, I have 1 coin that's inbound balance. So I can receive 1 coin. So what I can do if I really wanted to buy this 3 coin item is I could take channel 1 and I could pay back to myself on channel 2, and then channel 2 would have 3, and then that channel would now have sufficient balance to actually buy that 3 coin item. So that's a way to do larger payments without even having multiplexing. So today we have these 2 cases where you could, if you need to buy something and it costs a bunch, that these are possible ways to do it. So the third case is where we run into trouble. Like you have 2 channels and both of them have insufficient coins for what you want to buy, and so you're kind of out of luck. So that's like where multipath payments like comes in as a solution. So there's another thing to consider with multipath. That's not just about like can I pay or not, or can I not pay. It's also can somebody observe that I'm paying. So if you can look on this in the upper half, I kind of show an example of somebody who's buying like a Y'all's article. And so if that person A is sending 150 Satoshis across the network, then person C can kind of see as they pass that 150 Satoshis across to Y'alls.org, they can kind of have an idea that that payment is going to Y'alls.org because it's 150 and that's like the standard cost of an article on Y'alls. So it's a pretty good idea that that's what you're doing. So one advantage of multipath payments in the future could be that we could split up this values to make it less obvious. So we could say, instead of spending 150, A is going to spend some random amount through C and some other random amount through B, and together they're going to add up to 150 on the other side. But it makes it harder for like C to tell that that payment is actually going to Y'alls.org. So that's another reason why you would want to use multipath, and a limitation of the current protocol that doesn't really have multipath. So there's multiple ways to do multipath, and one way that I'm not talking about is what we've proposed at Lightning Labs called atomic multipath payments, which uses sharded pre-images. And that idea is that you would split up the pre-image into multiple different components. And then the only way to put it back together is if the payment is completed atomically. So I get all of the payments together. But it's kind of complicated to implement. So we have different ideas of how we can do multipath payments before we get to that complicated state. And one of the easiest ways to do multipath payments is this idea called link-level multipath payments. And I can kind of show how that works. It's very simple. So in this diagram, you can see that the route begins on the left, and then it goes through the router, and then it gets to the end. And this is representing, so at the start, I have two channels, and both of them have one coin. And I go to the router, and my goal is with the router is that they're going to relay my payment of both of these different one coins into a two coin payment. So if you think about like how HTLCs work, it's kind of like a two-phase commit system. So I get in HTLC, and then that becomes part of my commitment transaction, and then I pass forward that commitment to the next node, and so on and so forth. And then only after everything is already kind of like locked into the commitment transactions do we then begin like the second phase of the commit, which is to reveal the pre-image and then roll it back. So what we have today is we have a situation where in L&D we have people who have a bunch of channels, like I have multiple channels to the same peer. So what I could do is I could actually talk to my peer, and I could say, listen, I want you to forward these two coins, but I don't have a single channel that has enough for these two coins. I only have a one coin channel and another one coin channel. So what I'm going to do is I'm going to put one HTLC on you, and I'm going to ask you to forward a two HTLC. So I'm going to put one coin on you, and then I'm going to say, oh, can you send a two coin? And that peer is going to say, well, I'm not going to do that because I'm going to get one, and then I'm going to spend two. That's not going to make sense. So, but then I can say, oh, well, actually, I have another channel which has another coin. So before you forward that on, I'm gonna attach another one coin to you. So you're going to have two incoming HTLCs, and they're going to be locked to the same pre-image. And that's when you have this commitment transaction, you're going to know that, oh, I have these two incoming HTLCs, and they both are locked to the same pre-image. So that's going to make it now make sense to me that I'm going to be able to pass out an HTLC on the other side that spends two, because I'm going to be able to, once I send this out and I get the pre-image to get two, then I'm going to be able to collect these two separate payments on both these different channels. So you can kind of like arrange this without even like telling anybody in the network about it, but you do need to have some kind of protocol so that both of the different peers like understand how to talk about this. Yeah.
Do I have to have two channels with the route, or would this technically work in the sense of I have one channel with the route and then the other one is just another route to the route? So I would tell the route, hey, you accept this HTLC and there's another one incoming on some way.
Yeah, I think it should be fine, but you'd have to be a little bit. So you want to be a little bit careful. Like, so one thing to think about with this type of strategy is like you're kind of breaking the rule of never use the same pre-image twice, right? Like you need to be careful that you stay in the two-phase commit scheme. You have to be careful that you're in the first phase where you're just kind of like waiting to reveal the pre-image. But otherwise, it could potentially work, but it just might be a little bit more complicated. So the big advantage of LinkLevel AMP is like you are really only caring about these two different peers, and they can like have their own protocol that nobody else in the network really needs to care about. Okay, so this is like the smarter edges, and it only extends like one peer. So it's like the benefit of it, and it's also the limitation. And Renee has a good point that potentially it could be extended more. And I'll kind of get into that now with BassAmp. So BassAmp is another kind of, it's using the same principle, but it's making it a little bit more general. So in this example, you can see like, I'm trying to buy something that costs two. And the receiver of the seller who's selling this thing that costs two, he has 2 inbound channels, and both of them have 1 coin only. So normally he wouldn't be able to receive the 2 coins because he only has these 1 coin channels. So what I can do, but if we can arrange things so that he'll wait, I can actually still pay him too. And the way that will work is at that I'll first pay him 1 over the top channel. So I can do that because I have 2 coins in my channel, and then the routing node has a 1 coin channel. So I'll first pay him, but he won't accept that HTLC because the item costs 2 coins. So that's not enough to actually give over the item. So then what I'll do is I'll pay another payment, and it'll be locked to the same preimage. And it's safe to do it because the preimage hasn't been revealed yet, and we're still in this first phase of the 2-phase commit where we're just like setting up our commitment transactions. So he'll get the second payment, and he'll then like do the math. He'll be like, oh well, I can add up. I have a 1 coin incoming HTLC, and I have another 1 coin incoming HTLC, and now it's safe for me to reveal the preimage because I'm going to get the payment that I want, and everybody's already locked into their positions. So it's not like you can mess around and then use that preimage to steal money from somebody. So it will then rewind back to the beginning of in the same way that payments normally go, and you will have successfully bought something for 2, even though there's no channel that exists that has 2 by itself. Yeah.
How would you prevent the merchant from not revealing the preimage before the second HTLC is constructed? And then you paid me 1, but not enough, so tough luck. Or I don't know.
Yeah, that's kind of a problem. So you need to make sure that this protocol is followed, and I call it like economic code. So it's based on like economic logics. Why would I accept a 1 coin for something that I'm selling for 2 coins? Especially if we pre-negotiated this. Like if I told you, oh, I'm not going to be able to pay you all in one HTLC. You're going to have to wait, for multiple HTLCs to come in. Then why would you take that 1 coin? But technically you could. So that's why something like atomic multipath payments that uses like a sharded preimage might be preferable in some situations.
In combination with an invoice, you're actually providing for a proof of payment for a partial payment. So I would have an invoice and I would have the payment preimage. I could then go and say, okay, I paid, right? You now give me my coffee, but the merchant the merchant only received like half of the payment and is now forced to act on that partial payment. So it's an economic argument.
Yeah. But this also, the advantage of this scheme as well is that it doesn't really require any network changes. As far as the nodes see that you can take different paths through, and the economic logic works at every step. So even if you don't want to commit to 2 HTLCs at the same preimage, you don't have to. So this is something that we could even see as being useful with submarine swaps. So that's something that we're thinking about of how we would actually put this into use. If you wanted to swap multiple channels. So I want to do a submarine swap where I want to reduce the on-chain footprint of my swap. So what I can do is I can do I can empty out lots and lots of channels, and then I can turn those all back into one on-chain transaction. So in that case, we also don't have to really worry too much about this. The economic argument is a lot stronger in that case, because it's why would I ever accept less than what the thing cost? So I think there's a lot of different applications, and this is more like a near-term solution that we could deploy to the network without having to wait for Schnorr or soft forks or anything like that. Okay. I guess I can move on to key sending. That's all that I had on multipath. Maybe there's some questions about multipath though. Cool. Covered everything. Oh, Renee.
Well, I mean, I talk about multipath payments a little bit too tomorrow, so I mean, there are some criticisms with multipath payments. So the question
No,
is,
there aren't.
we could discuss them now, but I have them in my slides tomorrow. So
I mean, I'm interested. Maybe I don't have an answer though. What are some criticisms?
So, for example, with multipath payments, you lock up more HTLCs statistically. So overall, you put more data on the blockchain.
Well, but you're
Yeah.
still limited to a 20x multiplier of your own funds. So the maximum route length that you can lock up on for HLCs is 20 times your funds that you are spending yourself, and that doesn't change whether you split them or not.
But if it's over more paths, it's different onions that you send out.
You mean your on-chain footprint changes?
So the thing is, first of all, there's more HTLCs locked up in the entire network. And if channels break, then also more HTLCs will hit the chain.
Right. Yeah.
Right. So this entire thing where we try to make the Lightning Network of reduce load from the chain, we now put more load on the chain. By
Yeah, I mean,
this
I think
construction.
a lot of these subjects we're talking about, they all like interlink with each other.
Mm-hmm.
So like, I'm by reducing the size of the HTLCs, I'm like reducing the economic incentive to pass it forward, right? Because like I'm going to have, maybe like I'm creating some risk that it will go to chain, and now it's like it could be if it does fail and go to chain, it could go to chain in a lot of different places instead of just one place. There's also like a question of complexity. Like, how do I like figure out the route for this? So instead of just figuring out one route, now I'm figuring out lots of different routes. That's a problem with atomic multipath payments. We have to like go to like flow routing.
So the one thing that we're looking into is basically having an adaptive multipath payment. So we try the first attempt, and then if that doesn't work due to capacity constraints, we split that and try two different ones. Generally speaking, we are discouraging people from using too many HLCs because we still have a base fee that is not proportional to the amount, and so you're actually paying for the HLCs you consume, but I mean, there is the impact on-chain footprint that might be negative.
Yeah, but this also goes in the direction that AMP routing is not so fast as regular Lightning payments, right? Because what
But it
happens
works
now is
where the others don't.
yeah, but if one route times out, I mean, we discovered this yesterday that we have to wait. Yeah, so now I'm splitting over 100 paths. One path is timing out. All the others are locking their HTLCs for this amount of time.
Yeah,
the entire payment is the maximum time of like.
I'd definitely say this is more of like an optimization that you wouldn't necessarily need all the time. And really, the key usefulness is if you like run out of the liquidity in your channels, and hopefully you're not doing that all the time, right? Like you want to be making your channels of a sufficient size that they can support many repeated payments, and you're not like running into this thing where you need to combine a bunch of different channels together in order to like pay that one thing. In that case, you might just want to go to the chain.
So the one key advantage that I usually mention is that it's a huge increase in user friendliness, because you don't have to think about how to allocate my channels. I can actually bundle all of my channels, so I can actually go back and have a single off-chain balance and not care about how these are actually mapped to individual channels, because the total amount that I have is always available independently of how I split it up.
Yeah, there's definitely like UI considerations, but even then though, like even if I think we're still figuring out like how to represent Lightning channels to users. So like in Lightning Labs app, we actually already show unified balance.
Yeah.
And we're working on like how to like message this, but also you kind of should think about not spending your entire balance all in one go with Lightning. Like you should kind of have that consideration that like this is like a spending wallet that you use multiple times. Right. You shouldn't really have this idea that like I have this one balance and I'm going to spend it all just in one shot, because like maybe the receiver couldn't.
No, I totally agree that you shouldn't be showing channels by default to users, but I disagree about me not being able to spend the $100 I have on my wallet when I want to spend $100.
It's definitely good. Like
I want to educate users less, not more, about what is good and what is not good.
Yeah.
And so the abstraction that I'm able to bundle channels such that I can perform bigger payments is a net win for me, not and we shouldn't reintroduce this technical detail from underlying layers back into the user behavior.
I don't know exactly like what the right abstractions are. I think like as we like develop it and release it to users and like see what they get confused by, like we'll figure out more about like what you have to know about and what we can just hide.